Hi, welcome to this lesson on number patterns, geometric sequences. We're going to be having a look at solving a geometric sequence problem, question 3. So in a geometric sequence, the second term is -1 and the fifth term is 1 over 27. We are asked to determine the formula for the general term of the sequence. So let us recall that in a geometric sequence, the general term is t sub n equals a times r to the power n minus 1, where n is a natural number. Recalling that a is your first term and that your r is your constant ratio. The n denotes the position of the term, so the first term, the second term, the third term, so on, and this entire expression t sub n is the value at that position. So for example here, -1, that is the value at the second position in the sequence. So we need our variable a and the variable r to write the full general term of the sequence. So let's imagine this. We know that the second term, t2, well, we know if we put 2 into this equation or this formula here, it's going to be a times r to the 2 minus 1 is just 1. So we just write ar. And that's equal to -1. So that's our first equation that we have there. Next, we're told that t5, the fifth term, which if we plug into this general formula for n equals 5, I'll get a times r to the power 4. And that's equal to 1 over 27. Let's call that equation 2. Now, the common technique when you're given different terms and you want to solve for a and r, just like in the geometric sense where we're dealing with a constant ratio, the technique is to create a new ratio to try and get r by itself. So we look for the one that has the higher power of r. In this case, it's term 5, because it has an a times r to the power 4, which is greater than this ar to the power 1. So what we'll do is we'll divide equation 2 by equation 1, and this will give us the following. ar to the power 4 divided by ar to the power 1 equals, now on the right hand side we have 1 over 27 in the numerator here, divided by -1 in the denominator. On the left hand side, these a's will divide out because everything's being multiplied, and the r to the 4 over r to the 1, exponential laws say that because they're the same base and you're dividing them, you subtract the powers, so r to the 4 minus 1. On the right hand side, we have 1 over 27 divided by -1. Well, anything divided by 1 is going to be that same number, but in this case it's going to be negative of that number because of -1. So this becomes -1 over 27. Therefore, we have r to the power 3 equals -1 over 27. Okay, so now to solve for r, remember when you're solving an equation here with an exponent 3, we need to do the inverse algebraic operation. So instead of cubing it now, we're going to take the cube root on both sides. So if I take the cube root of r cubed, that must be equal to the cube root of -1 over 27. So the cube root and the cube will cancel. Therefore, we have r equals, and let's pull up our calculator and check. Well, if we take the cube root, so on your calculator, where you have x to the power of, you'll see above there, if you press shift x to the power of, we can now put a 3 there to represent the cube root, and it is -1 over 27. So I get -1/3. So therefore r equals -1/3. And that makes sense because if you multiply that by itself 3 times, -1/3 times -1/3 times -1/3, negative times negative is positive. 1 over 3 times 3 is 9 times -1/3, and that's going to be -1 times 1 is -1, and 9 times 3 is 27. So you get back r cubed equals -1 over 27. So that's our correct ratio value. And how do we find the a value? Well, we sub this. So sub into equation 1, because it's the simpler one. So if we have a times r equals negative 1. How do I get rid of negative 1/3? Because it's division. The opposite operation of division is multiplication. So I need to multiply both sides by negative 3 to undo this negative 1/3. So doing that, I'll get a equals negative 1 times negative 3, which is positive 3. Therefore, the general terms given by Tn equals 3 times negative 1/3, all raised to the power n minus 1, where n is a natural number. Okay, so the way I've written it is the exact form. And notice how careful I am about the brackets around that r value, because the exponent n minus 1 is only acting on that base, negative 1/3, not on the number in front of it, which is 3. Right, and that's how we'll solve this problem. I'll see you in the next one.